As we continue with Chapter 7, Estimating Parameters and Determining Sample Sizes, we are going to be looking at estimating population means in Section 7.2. The objective here is to construct and interpret confidence intervals for a population mean. So in 7.1, we learned that you can estimate a p using a p-hat and create an interval around p-hat by adding and subtracting e, where our margin of error was z sub alpha over 2 times the square root of p-hat times q-hat over n. In 7.2, we're going to learn how to estimate a mu using a point estimate of x bar and how to create an interval around x bar. So let's look at this example here. You've been to many coffee shops and restaurants in the area, and you notice that some places serve their drip coffee at a much hotter temperature than others. Suppose you're curious of what the average temperature is for the coffee shops in the area. How would you find out? So since it's too time-consuming and expensive to travel to every restaurant and coffee shop in Raleigh, you decide to go to 24 randomly selected locations. At each location, you order a regular drip coffee and you measure the temperature when it is served. What would you do next to estimate the mean temperature of all coffee served in Raleigh? Well, you would find the mean of your sample as a place to start, and then you're going to find a margin of error to account for the variability. So to find a confidence interval for mu, we will have some steps to consider, and there's going to be more details as we move forward. So the first thing you're going to do is find your point estimate. Then you're going to calculate the critical value based on your level of confidence, calculate the margin of error, add and subtract the margin of error to the point estimate, and then interpret the confidence interval. So that first step of finding the point estimate for mu, the best point estimate for the population mean mu is going to be this sample mean x bar. If you are given raw data, then you're going to use equals average and select the data in Excel. And then there are times that you may be given the sample mean in a summary. The critical value, when we were finding confidence intervals for p, we used a z-score as a critical value. For mu, we are going to use the t-distributions to find the critical values. In 6.4, we learned that x bar is approximately normally distributed as long as n is greater than 30, no matter how the original population is distributed. The t-distribution is used to describe the distribution of x bar when the population is approximately normal, no matter what the sample size is. Your t is equal to x bar minus mu divided by s over the square root of n. Okay, so you're going to do your x bar minus your mean divided by the standard deviation over the square root of the sample size. You will see something called degrees of freedom as we are looking at a t-distribution. Finding a critical t-value requires knowing the degrees of freedom, or df, which is always 1 less than the sample size. So that is just n minus 1. As the degrees of freedom gets larger, the t-distribution approaches a standard normal distribution. All t-distributions have a mean of 0, just like a standard normal distribution. As the degrees of freedom increase, the standard deviation of the t-distribution gets closer and closer to a z-distribution. And you can kind of see here in the image of the green is the standard normal distribution, and as the n changed, it gets closer and closer to that standard normal distribution. The second step is to calculate the critical t-values. We will be using Excel to find the critical t-values. If C is the level of confidence, A is, or alpha is 1 minus C, and the degrees of freedom is n minus 1, then we're going to use this new formula of t dot inv dot 2t parentheses alpha comma the degrees of freedom to find the critical t-value for the margin of error. Then we'll calculate the margin of error, and we'll use the formula E equals the t value times the standard deviation divided by the square root of n. Then we're going to add and subtract the margin of error. So remember, to find that lower endpoint, you're going to be using x bar minus e. The upper endpoint, you're going to be doing x bar plus e. And then you'll have your confidence interval written there. And when you're finished finding the confidence interval, you're going to write a concise sentence to summarize the estimate. Remember to always include the 4 things: confidence level, the parameter you're estimating, what is the interval itself, and put it into the context of the scenario. So here's all the steps together. You're going to find the point estimate x bar, and you may have to use equals average and select the data if you're not given that in a summary. Find the critical value, that's your t, based on the given confidence level. Determine the margin of error. Subtract e from x bar, and then add e to x bar to find the upper endpoint, and then, of course, finish with that interpretation. I like to always set my confidence intervals of a mean up the same way, and here you can see a little screenshot of how I set my Excel up. So I do my n and then find my degrees of freedom, confidence level alpha, then I'm going to use enter my x bar, my standard deviation, find the t-score, and then you'll have your e, and then your upper and your lower endpoints. So let's take a look at this example for coffee temperature. We already know we're looking for that we want to know the mean temperature of coffee served at shops and restaurants in Raleigh. So you go to 24 randomly chosen locations and measure the temperature. Assume coffee temperature is approximately normally distributed. The table below gives the temperature you found in degrees Fahrenheit. We're going to construct a 95% confidence interval for the mean temperature of coffee served in Raleigh. So because you're given the data here, you're going to have to put this data into Excel and then do equals average and select the data to find that point estimate x bar. And then you're going to find that critical t value. So remember, you're going to use t.inv.2t, the alpha, and then the degrees of freedom. Determine the margin of error. And if you're using Excel, which you should be doing cell referencing. Then you're going to add and subtract e to and from the x bar, and that's going to give you your lower and upper endpoints. And then, of course, you're going to interpret the confidence interval in the context of the problem. And in this problem, we would say we are 95% confident that the true mean temperature of coffee served in Raleigh is between 171.22 degrees Fahrenheit and 176.03 degrees Fahrenheit. Here you can see my Excel sheet all set up. I have the data at the top, and then I have all of my information below. You can see what came from the problem and which formulas I used. Here you can see some interpretations that would be incorrect, and we're going to look at why they are individually on the next slides. I do want you to remember that confidence intervals are about a single number, the parameter. And in this case, that is the mean temperature of all coffee in Raleigh. So that first interpretation was 95% of coffee served in Raleigh is between 171.22 degrees Fahrenheit and 176.03 degrees Fahrenheit. Why is this wrong? This statement is about the values of individual data points, but our process provides an estimate for a single number, the population mean. You also can see that it's wrong because we see this 95% of coffee served in Raleigh, and we're not talking about 95%. Our confidence level is 95%. The second interpretation said there is a 95% chance that when you go to a coffee shop it will serve coffee that is between 171.22 degrees Fahrenheit and 176.03 degrees Fahrenheit. Why is this one wrong? Because we should not talk about the confidence level, in this case 95%, like a probability. So you want to make sure that you avoid probability words like chance or probability or likelihood. The third interpretation said we are 95% confident that the mean temperature of coffee served at these 24 locations is between 171.22 degrees Fahrenheit and 176.03 degrees Fahrenheit. This statement is about a sample mean, and it says these 24 locations. However, we know for sure what the sample mean is because we calculated it in Excel. We are 100% confident that the mean temperature of these 24 locations is 173.625 degrees Fahrenheit. Instead, our confidence interval should be stated in reference to the population parameter. That's the mean temperature of all coffee in Raleigh. Here we're looking at an example for high school GPA. A tutoring center wants to know the average GPA for high school students in their community. They randomly select 350 students from their area to find the mean GPA for those students at 2.576 with a standard deviation of 0.529. Construct a 99% confidence interval for the mean GPA of students in this community. So in doing this in Excel, right away I would start putting in the information that I know from reading the problem in the Excel format that I showed you guys earlier. Here is the worked out problem, and you can see everything. Again, this is just worked out as is, and we are saying that we are 99% confident that the true mean GPA for high school students in this community is between 2.503 and 2.649. Here you can see the confidence interval in Excel. So again, I have my N value, and I went ahead and did my degrees of freedom, my confidence levels from the problem, and you can find alpha just by doing 1 minus your confidence level. X bar came from this problem. Instead of having to find the average, you were given the mean. The standard deviation also came from the problem in this case. Then you're going to find your T-score, your E, and then your lower and upper values, and make sure that you interpret in terms of the problem. Here's an example. I'll let you guys read through this, and then I think you should try this example on your own, and then you'll see the answers on the next slides. Here is your table of data given. You're going to find the point estimate for the mean incubation time, and then find the confidence interval for 90% confidence, 95% confident, and 99% confident. And then, of course, interpret each interval in terms of the problem for the evil scientist. You may pause the video here and then work the problems and come back, and you'll see the answers on the next slides. To find that sample mean, you will need to put your data into Excel and then do equals average and select the data. Here you can see those interpretations for each one. You can now complete lab manual pages 74 to 76 and your MyStatLab homework section 7-2. Of course, if you have any questions, please comment in the Teams channel for Unit 3 questions.